I wanted to talk a little bit about some of the pitfalls in working with Slicer. Let's assume that you're able to read in the data and you have the box here ready to visualize in Slicer. First thing that you always want to do is under the view, make sure that auto render is checked. This will mean that if you make a change, it will be immediately updated on the screen. It's much more easy to work with Slicer if auto render is turned on. The next thing before you do anything else is you should look at the range of your data. Under view, choose range. And this gives you a histogram of your data. You can scroll up here and see, manipulate the y-axis. And as you can see, in this case, all of our data is clustered down at one range of the color map. So we're not going to be using very many colors here to show our data. It would be better if our data were spread out over the full color map. And in other words, the data really, if I bring this back, I can see the data really only goes between, let's say, -40 and +80. This is the true extent of our data. And so if you have that situation, unfortunately, the only thing you can do is to go back and read the data in again, specifying those limits. So we'll go through that process now. Here is my data file. It's ASCII. Size is 61 cubed. And then here in the data range, I can specify those values that I had just found. And if we preview it, we can see it's using much more of the color map. All the different colors are being shown there. We could have also surveyed the data to get what is a reasonable range. Remember auto render. Gotta do that again. Now, another pitfall is having isosurfaces that have values that are too small. Let's demonstrate that. View isosurfaces. Here we create a new surface. Let's intentionally make this value somewhat near the middle here. I'll choose a value of 1 for the ISO value. See what this looks like. I have to turn off the box and turn on the ISO surface. So here's a surface where the value of the function is 1 everywhere on that surface. And it really doesn't look like a d orbital. It's because we're looking at an ISO value that is much too small to really show the full extent of the orbital. We do sort of see the nodes there. You see that X, but there's this cutoff, and the ISO surface is coming up against the edge of the box, and then there's no data out here to show the rest of the orbital. So you've chosen a value here. If your renderings look like this, you've chosen a value that's inappropriate for your data set. You need a much bigger box to show the orbital with that ISO value because it's chopping it off here at the edge. So we can go back and adjust that, move that, make it a much larger value. And also, let's do both positive and negative values. So you can see your rendering looks quite different if you choose an isosurface that's contained within the box, and if you choose both positive and negative values for your isosurface. This looks a lot more like a d orbital.